Hello students, in this session we are going to study the cantilever beam with UDL. Our aim is to find out the deflection and slope for a cantilever beam with UDL using the double integration method. So we are going to study about the double integration method, DIM, double integration method, and deflection and slope. So we have applied a UDL on a cantilever beam and the load is W kilonewton per meter. W kilonewton per meter is the load, and we know the formula. Formula is EI d2y by dx square. This is the deflection equation, that is equal to minus m at a distance x, right? So if we take the moment at a distance x from the free end, suppose this is A, this is B, B is our free end. So what will be the moment at a distance x from the free end? The load of this part is Wx. Load of this part will be W multiplied by x, acting at the center and at a distance of x by 2 from the x, because it is at center. So if this total is x, this will be x by 2. So this distance is x by 2. So moment of this will be equal to mx will be equal to wx multiplied by x by 2. So minus, because it is a hogging bending moment, minus wx multiplied by x by 2. So this will be equal to minus wx square by 2, small w x square by 2. So this is the bending moment at a distance x from the free end, right? This is valid for the entire beam from B to A, because there is no other load in between. So we can write from here, we can write that EI d2y by dx square will be equal to minus mx, which is minus wx square by 2. So minus minus plus wx square by 2. So this is our basic equation, deflection equation, which we have to solve, right? Now integrating this equation, we will get the slope. So integrate this equation, you will get EI dy by dx. By integrating, EI dy by dx will be equal to integration of this term, wx square by 2, this is wx cube by 6, wx cube by 6 plus some c1 constant, right? But c1 is unknown to us. How to find out c1 now? C1 is not known to us, it is unknown, right? So how to find out C1? For C1 we can use the boundary condition. If we see the deformation in this will be like this, and we know the boundary condition. What are the boundary conditions? Boundary conditions for cantilever beam is at the fixed end where the length is L, at the fixed end, x is equal to L, dy by dx will be equal to 0. This is the first boundary condition. And also at x is equal to L, the slope, the deflection is also 0. So slope is 0, deflection is 0 at the fixed end, right? So put this boundary condition, dy by dx is 0 at x is equal to L. So at x equal to L, dy by dx will be equal to 0. Put here, you will get the value of C1. So EI, this is 0. So C1, by solving this, you will get the C1. So C1 will be equal to minus WL cube by 6. So this is the one constant C1, right? So put here, we will get the new equation, that EI dy by dx will be equal to Wx cube by 6 minus WL cube by 6. This is the slope, right? Slope equation. So EI can be taken on the right hand side, and we can get the slope theta, which is given by dy by dx. The slope tan theta or theta will be equal to dy by dx will be equal to EI can be divided on the right hand side. So Wx cube by 6i EI minus WL cube by 6 EI. So this is the slope, right? So this is the one of the answer which we have to find out, the slope of this cantilever beam. At any distance x, we can find out the slope as a function of x, right? So this is the one of the equation, right? Another equation is to find out deflection. So we have to integrate this equation again, once again. So suppose this is equation number 2 and we have to integrate it. So integrate equation number 2, integrate equation number 2, what we are getting is EI and integration of dy dx is y, EI is constant, right? And that will be equal to, now it is x cube by x cube, the integration of x cube is x to the power 4 by 4. So this will be w x to the power 4 by 4, it will be 24, minus w l cube by 6x plus some constant c2. There is another constant c2. How to find out this c2? C2 can be found out from the second boundary condition, that x is equal to L, y is equal to 0. Put here and you will get the C2. So at x equal to L, y is 0. There is no deflection at length L. Here there is no deflection, right? So at x is equal to L, y is 0. Put here, you will get the value of C2. So what is the value of C2? By putting this boundary condition, put y is equal to 0 here, x is equal to L here, x is equal to L here, and find out the value of C2. So C2 can be obtained WL power 4 by 8. WL to the power 4 by 8. This is C2. This is another constant. So C1 was this, C2 is this. Now we can put here and we can get the deflection y. Y deflection can be obtained. So y will be equal to, put the value of C2 here and we will get the deflection, total deflection. So y will be equal to wx to the power 4 by 24 EI. EI can be taken on right hand side in denominator. So it will be wx to the power 4 by 24 EI minus WL cube by 6 EI multiplied by x plus the value of C2, that is WL to the power 4 plus WL power 4 by 8 EI. So this is the value of y, the deflection as a function of x. So deflection as a function of x, right? And the value of y as a function of x. So at any x we can find out the value of y. Suppose this point is x dash. So x dash is the deflection, right? So we can find out y at a distance x. So at any distance y, we can find out the deflection using this equation, right? But our aim is to find out the maximum deflection and maximum slope. So you can see here the maximum deflection will be point B point, right? So at point B there will be maximum deflection and maximum slope. So this is our y max. This is y max, maximum deflection. Also the slope is maximum at this point. So this is the theta max, right? I'm proving it. So mx was minus wx square by 2, and here I want to show the slope I want to show here at point this. So this is the slope, right? Theta max. So this is the slope, this is theta max. This point was b to b dash. So slope will be maximum at this point. At b point slope will be maximum, as well as deflection will be maximum, right? So maximum slope and deflection will be at x equal to 0, because at b point the x is 0, right? Because x is starting at this point, right? So at x is equal to 0, so put the value of x is equal to 0 in this equation, you will get the maximum slope, right? So theta max will be equal to here x will be 0 in this equation, and you will get minus WL cube by 6 EI, minus WL cube by 6 EI. So this is the maximum slope. And maximum deflection, put in this equation, and you will get the maximum deflection. Put the value of x equal to 0 in this equation. X 0, it will become 0. This term will become 0 because x is 0, and this is the maximum deflection. So y max will be equal to WL to the power 4 by 8 EI. WL to the 4 by 8 EI. So this is the maximum deflection and maximum slope. Let me confirm. WL to the power 4 by 8 EI and minus WL cube by 6 EI. So this is the maximum slope and this is the maximum deflection for a cantilever beam which is loaded with UDL on the entire length. So this is how we can find out the slope as a function of x and maximum slope, deflection as a function of x and maximum deflection.